Hello everyone, welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain something. Next, let's continue exploring the classification of machine learning. The one way to classify machine learning is based on the task it performs. Machine learning task has been categorized to several types. Here are some common classifications. Firstly, we have the clustering model. This model is utilized to divide the training data into multiple clusters is based on specific relationships. It aims to group similar data points together within this same cluster, forming clusters that share similar characteristics or patterns. Classification is another widely used task in machine learning. It involves determining whether an item or data point belongs to one of the predefined categories. It is commonly employed to classify objects or instances into different classes or categories based on certain features or attributes. On the other hand, the regression model focuses on predicting the value of a particular variability rather than assigning it to a category. It deals with continuous values that can be seen as extensions of classification model, where the label value is not limited to discrete values but take on range of continuous values. Lastly, we have the tagging model, which is employed for handling sequence-related problems that exhibit correlations.
This model takes the input sequence of observations
and produce an output sequence of all responding tags. It is commonly used in talks as art-of-speech tagging or named entity recognition. Another way to classifying machine learning is based on the learning process involved. Let's take a look at these categories. Supervised learning, focused on labeled training data. In this process, the machine uses the labeled data to learn a model. The objective is to train the model to accurately labels or predict the outcomes of unlabeled test data based on the knowledge gained from labeled examples. In contrast, unsupervised learning works with unlabeled training data. It automatically learns patterns, structures, or relationships from data without adding predefined labels. The goal is to build a model that captures the underlying patterns and can be used for tasks such as clustering or dimensionality reduction. Semi-supervised learning combines elements of both supervised and unsupervised learning. It leverages a small amount of labeled data along with a large set of unlabeled data. By incorporating the unlabeled data, the model can further enhance its understanding of the underlying patterns and improve its performance. Machine learning finds a wide range of applications across various domains. Let's explore some of these applications. Firstly, we have speech recognition. In this field,
machine learning techniques like GMM-HMM or SIGAS mixture model, hidden Markov model, and RN and the recurrent neural network or cyclic neural network are utilized to convert.
Neural network are used to convert spoken language into written text. These models help computers understand and interpret human speech,
enabling voice commands and text transcription services.
Next, we have computer vision. Deep learning models, a subset of machine learning. A widely deployed machine in computer vision tasks. These models are designed to recognize and interpret visual data, allowing machines to understand images and videos, perform object detections, facial recognitions, and much more. Moving on to natural language processing, or say NLP. Machine learning plays vital roles in tasks like language translation, sentiment analysis, and text generation. NLP models leverage techniques such as reinforcement learning and supervised learning to understand and process human language, enabling applications like virtual assistants, chatbots, and language understanding systems. Another important application areas is big data analysis. Machine learning algorithms are used to analyze large and complex datasets, extracting meaningful insights and patterns. By applying machine learning techniques such as clustering, classifications, and regression,
in-depth analysis of diverse data can be performed,
leading to vulnerable discoveries and informed decision-making. So, today, our focus was on the fundamental steps of machine learning, the concepts of data preprocessing, and the various perspectives of machine learning, classifications, and its applications. That's today's lesson, and to see you in the next class.